Welcome, I'm Tom Tullock, Chief Commercial Officer here at ProcessMiner. It's my pleasure to introduce you to ProcessMiner University, a podcast series highlighting thought leadership in the manufacturing industry. I'm pleased to introduce today's host, Sydney Reckton. Sydney's a data scientist from Solenis who will lead a panel discussion on autonomous control for the pulp and paper industry. Sydney, thank you for agreeing to host today's ProcessMiner University class. Now take it away.
Hey everyone, welcome to an episode of ProcessMiner University. Today we have Chitta, Ranjan, and Matt Callicott to discuss the impact of AI and autonomous control in pulp and paper manufacturing. This is a conversation between ProcessMiner and Solenis. I'm your host, Sydney, and I'm a data scientist with Solenis. As a resident data science, I leverage my unique blend of papermaking experience and data analytics to help develop and support analytical product pipelines, including the Optics Applied Intelligence platform. I have a bachelor's degree in chemical engineering from North Carolina State with a minor in pulp and paper technology and a master's degree in analytics from the Georgia Institute of Technology. With me today, I have Chitta Ranjan, who is the Director of Science at ProcessMiner. He earned his Ph.D. from the Milton Stewart School of Industrial and Systems Engineering at Georgia Tech, and he works on developing real-time AI systems for manufacturing industries with the goal of making them autonomous and sustainable. He serves on multiple boards of directors in the analytics and engineering space. I also have Matt Callicott, who is the product launch manager at Solenis. With more than 7 years experience in over 100 paper mills throughout North America, Europe, and Latin America, Matt works to help develop and expand the Solenis data analytics platform. He helps customers drive more accurate, data-driven solutions from the ocean of data in a dynamic manufacturing process. He holds a bachelor's degree in chemical engineering from Georgia Institute of Technology. Guys, I'm so excited to have you on the podcast today. It is just mind-boggling to know that we are autonomously controlling aspects of the pulp and paper manufacturing process. And it really feels like not so long ago we were doing hand control charts using rudimentary statistical process control to drive optimization. But now we're using AI and performing autonomous control with computers and the cloud and all these other buzzwords we could come up with. I would love to hear from you about what the major obstacles that you think you had to overcome, the industry had to overcome to get to this point to be able to run autonomous control algorithms in pulp and paper manufacturing.
Yes, first, good afternoon, Sydney and Matt. You're right, Sydney. If we look back where manufacturing industries, typically paper industries, where they were in terms of controlling their process, and we have come a long way from there, and I'm happy we had been part of bringing or walking with the manufacturing industries, this journey of having AI for manufacturing. AI for manufacturing in itself is a large field, it's a large area, it's a long journey, and one of the major paths in this journey is autonomous manufacturing. If we could achieve autonomous manufacturing, we become more efficient in terms of producing, having high throughput with good quality, and have less scrap rate. These are the usual objectives in most of the manufacturing plants I can think of. Before I go further into what we did and how we got this far on autonomous control, I will first explain what do we mean by autonomous control. Machine automation is not a new word. It has been there and talked about for a long time. And I think it started around in 70s, 80s when people started to have developments in robotics. Robotic development happened for a long time, and now we have most manufacturing plants who use some element of automated robotic system to control the process. But where robotic or such kind of automation became limited was any manufacturing or continuous manufacturing process specifically, they have several parts. continuous manufacturing, like in paper manufacturing, this whole process has several components. The machine is a huge machine. I went to one of the paper manufacturing mills and it was huge. A machine was, I think, half a mile long.
Yeah, they're giant.
Yes, exactly. And you see raw materials coming, which is like chemicals, tree pulps coming on one side of the machine and then becoming paper on the other side. It's a process. Several pieces, several components interacting in this process. And where typical automation does not work is in understanding this all the pieces together, how they interact with each other and how they're affecting the final product quality. They do not easily comprehend that, and therefore it is hard to automate such kind of processes.
That's putting it nicely.
Yeah, and this is where the advancement stopped or hit a wall. And that is when AI comes in, and we brought AI to cross that wall and bring automation in such a way that you can look at all the pieces of the machine together, how they are interacting, and then use that learning to control the process. And we have developed such an AI system that can control the process with the objective of producing product of the right quality. When I say right quality, I mean simply within spec limits, and while minimizing your cost, various types of cost, raw material cost, human cost, and so on. How did we get here? And I'll go backwards. Now, autonomous control in a real-time manufacturing process like paper. What is required to have real-time autonomous system? A real-time AI. And when I say real-time AI, what will feed a real-time AI? A real-time data. How to get a real-time data? You need to have connectivity with very low latency. You have to have a mechanism that you can fetch the data in real time and use that to control your machine autonomously. One major item I said here is a real-time AI. How to develop a real-time AI. Besides the aspect of computation and everything, let's suppose we can handle the computation. We have high-speed computers now. Suppose we can handle it. The major challenge that still remains in developing a real-time AI for continuous manufacturing processes is the nature of the process itself. It is extremely dynamic. And when I say dynamic, Matt can also shed some light on the dynamicness of the process. Matt, do you want to say a few words on dynamicness of?
Yeah, absolutely. You kind of covered it earlier, but the challenge that paper making is, especially, is there's just so much variability coming in with the raw materials, and you're trying to make the most consistent product possible, and you're trying to run it as fast as you can with as little downtime as possible. So there's just so many different places that variation can get pushed into this system, and so cutting through the noise is just, it makes it so challenging to really understand what's going on with this process. And I think that's something that ProcessMiner has done a really good job to help simplify and help people understand kind of what's going on with this. You know, there's an ocean of data, like kind of as Sydney started out the podcast saying, and it's just really hard to see through the noise. You know, they have 3 or 4 process engineers that are out there trying to figure out what's going on with it, and they're not very successful with it. So any extra steps that we can kind of bring to them, and any extra visibility that we can, has been very well received, and so far really helped us drive forward, you know, this AI initiative.
So Chitta, you working with ProcessMiner, you guys have actually done this though, right? I mean, we have a highly variable manufacturing process, a ton of data, and a really complex system to work through from an analytics standpoint, but you're successfully running your artificial intelligence products via autonomous control at pulp and paper manufacturers today, right?
Exactly, yes. And because we understood the challenge at the very beginning, and when we realized the challenge and enormity of it, we worked towards resolving it, and we have successfully done that. And I'll explain at a high level the challenge itself and how we have addressed it. Matt has already explained some part of it. when we say variability or dynamicness of the process, in more specific terms or more specific examples, some of them I can give right now. These are big machines with so many components, and these components degrade with time. As they degrade, the way they affect the product will change. It will not remain the same, and that means that the interactions have changed. Then you were using one type of raw material yesterday, today you are using another type of raw material, now things change. Then all of these things are interacting within themselves so much that when any one of them change, how their interactions have changed, you have to keep track of all of them.
And one thing that we didn't cover, the human aspect too. I mean, there are some guys that run their machine because they know this is how they do it. And there's other guys that think it's the exact opposite. And so that's really where we're able to kind of cut through some of that and help these guys understand how they actually should be running their machine and not just a gut feeling that may drive them even in more variation than we know about.
Exactly. And that's why we see so much variation shift to shift. One shift was okay, the other shift might not be. And yeah, so from AI standpoint, if things are changing so much, suppose we develop a model now, it is very likely that tomorrow it is not going to be relevant anymore. It won't work. And I'll give a quick perspective on the effect of this change by drawing an analogy from another type of problem, a simpler problem of, suppose, image recognition. We have other companies in the AI domain, such as Facebook, Google, and so on, who have done major developments in the field of AI as well. But some of the problems that we have there, for example, think of an image recognition problem. Facebook uses it big time for face recognition and things like that. Let's take an example of much simpler problem where I have to distinguish between cats and dogs. Now, cats and dogs, I have to distinguish them. I have to build a model. What will I do? I'll get some dump of data, some images of cats and dogs, train a model. Voila, I have a model. It can tell what is cat, what is dog. And I can pretty much use the same model forever, and it will be very accurate. It will always recognize what is a cat, what is a dog, because the features of cats and dogs do not change. But suppose tomorrow I want to use the same model to learn if something is a crocodile, a bear, a wolf. The model will start to break down because it does not know how to recognize it. And this is exactly the problem we have in manufacturing industries. You can build a model based on what you have till then, but tomorrow things have changed. So your model from yesterday is no longer relevant. And this is what we addressed early on when we were developing our systems. We developed our system in a manner that we did not limit ourselves. Our AI system is not limited by a model or a type of model. By that, what I mean is, AI has several subdomains. We have machine learning, we have deep learning, and so on. And within each one of this, we have so many variety of models. Now, one might be interested, which of these models are best suitable or most effective in manufacturing industries? And the answer is, you don't know. One type of model can be good today, but again, it cannot be relevant or effective tomorrow. So what we did is, do not limit ourselves with any small set of or a specific set of models. We have a library of models. Our library contains thousands of models coming from all types of machine learning algorithms, several types of deep learning models, several configurations of them. We put all of these models and we train them and let AI pick which one is the best. And we add a second layer to this, which is we constantly update all of this library of models, and the AI system is also periodically choosing which one is now the best. Meaning, several times a day, we train all of our models, all the library, and then at any point of time, the system will find this one is working best. Then in the next interval, something else might be working better, AI will pick it up. Due to this approach, we have been successful in having a very accurate AI system for manufacturing processes like these.
This is really what differentiates us and really opened the door for a lot of customers when we're having these conversations. Because just like Chitta said, we've approached customers and they've immediately, their mind went to that one single first principle model, and it doesn't change, doesn't move. It maybe drove a little bit of value for 3 weeks, and then something happened, something shifted, and they got nothing out of it after that. And so many of these CTOs or technology officers that we're working with at the customer sites, when they first hear what we're talking about with this optics, autonomous control, it kind of goes through one ear and not the other, because they've been there, they've done that, and it didn't work. And then we get to that next step, we're like, wait, no, I mean, we're letting AI constantly update and constantly choose. So we are providing an accurate prediction every single second, every single time. And that really, it opens up their eyes, and they're like, all right, come in, let's talk and discuss a little bit more, because they know that was the limitation. This was an option, a decade or more before, probably more than that, I think Chitta was saying. But this is really that next step that, made it a viable solution for all these manufacturing processes.
So the product is finally, something that this industry and this kind of data and this dynamic process can benefit from. It's working. It's doing these complex, dynamic modeling approaches so that it's staying relevant in the face of changing conditions, which are hourly on a paper-making asset. But the manufacturer doesn't see all of that. They don't see what's going on behind the screen. They don't see what's going on behind what touches their mill, right? The autonomous control. So from a more tactical standpoint, Matt, what milestones is the manufacturer having to overcome and walk through to actually start autonomously controlling something in their process?
Yeah, absolutely. I'd like to thank the paper industry has been around for a long time, and so we're quite antiquated, and we're very much stuck in the past. But you'd be surprised as some of these new assets come on board. A couple of them we're working with were built in 2015, 2016, are, how
Wow.
well censored, how well and ready they are for AI. But then there's stuff on the other side of the table where, this mill has been open since 1918, and, they just got Wi-Fi in their coffee break room. So there's a couple more steps to keep moving forward. But it really is, there's been a great growth in the paper industry specifically as we move towards more of these data-driven solutions. We need live data to make this prediction. We talked about that earlier. And most mills have at least a basis for collecting some historical data. Some mills are much better censored and much better prepared to handle that, and some aren't, but we've been successful at making predictions on both ends of the spectrum, and so making sure that they are, at least in the 20th century, is step one, but there is potential to drive value across the board in all of these different instances, because a lot of times we are still making a lot of control decisions not really based on this data, based on gut feelings, or based on just passed down knowledge. And sometimes that's not the best idea, or sometimes that's not the best way to be moving forward with it. And so we've been very successful at opening some eyes and kind of showing them, the Google Maps route instead of the route that your dad taught you to drive home every day.
Right, right. Does the manufacturer understand, right off the bat, autonomous control, like what it means to autonomously control something, since they're, everyone, regardless of how antiquated the industry is, we've all used our GPS to get us from, the grocery store to mom and pop's house or wherever it is we're going next. So we all have a concept of what AI can do for us, and even in some regard, autonomous control. But when you're speaking with the manufacturers for the first time, or maybe when they're, becoming an autonomous control customer, do they fully understand what it is they're getting? And if not, how do you explain it to them?
That's a great question, Sydney, and it's definitely a spectrum. Again, some people understand analytics, some people understand statistical driven solutions, and a lot of people don't. Or a lot of times we'll get the question, "Hey, can you just run some analytics for us? I know you've gotten that once or twice, and it's just crunch the numbers. What does that even mean?" So it is definitely an educational period to kind of get people up to date and understanding what we're trying to do. But this is really where the autonomous control portion comes in, using AI to drive this, because seeing is believing in our industry. So the people that are making some of these decisions, that are interested in moving forward, once they see the value in their pocket, once they see the success that we're able to drive with it, it kind of opens up their book to kind of try and understand a little bit more. Everyone's a baseball fan, or not everyone, but at least I am. And so we've been hearing the word, analytics, throughout your broadcasts, or you've been hearing it when, Chitta was talking about AI driving facial recognition for Facebook, all these different things. But it is an educational period where you kind of have to sit them down and help them understand, no, this is really what we're using AI for. This is what the goal is, and this is what we'd like to try and successfully improve. Will you give us a chance to show you what we can do? And seeing is believing, for sure.
Do they confuse an autonomous control product with like an advanced process control loop?
Absolutely, occasionally. There are a lot of different control loops in a paper mill, so it's not new to try and use information to better control your process. Is it the basis weight, so how much fiber is going through this source? That has been controlled through a control loop for quite some time now, and people saw great benefit. There's a lot of different things all across the site. From the pulp mill to the paper machine, things are being controlled with APCs. But really the big next difference is, we're not just looking at when steady state is and where we should be trying to keep the machine, because historically it was good here. We are looking proactively at what's going on and how things are shifting, and making proactive moves, not reactive moves. We're actually driving where we should be going and making sure we are providing the maximum optimization that we really can do. So,
and that proactivity piece that comes from like a prediction running the autonomous control loop, right?
Exactly. So that is really the differentiation. That was really that step that opened some eyes, and people understood quickly. It's like, that's why we need this. We made it. I mean, for an example, what we're typically dealing with is it's a human-driven solution. So it's whoever's been working there for quite some time, and they have a good basis of knowledge because they have experience there. But it's the general, just human nature that we're slow to react. We want to make sure we're right, and so a lot of times they will hedge their bets. They won't react as quick as they need to, and then they'll overreact to make sure that they're not going to get in trouble. Name of their game is just making good product and not having too much of a busy night. I'd rather kind of sit in my chair and make sure everything's smooth going. So there's a big insurance policy.
Yeah, exactly. And autonomous control loop can do that for them, right? So instead of like hedging your bet, so that you can sit back and have a relaxing midnight shift, let the autonomous control loop control things for you at a more optimized state. And I think it's so interesting that, I feel like it's not so long ago, I can remember literally walking into a paper machine control room and seeing hand-drawn statistical process control charts. And now every manufacturer I interact with, every customer I deal with, at least has some idea of the analytics push in the industry, and at least has some idea that someone out there is autonomously controlling something in their process that they never were able to before. Actually, I would love to hear what are some things right now today that are being autonomously controlled using the ProcessMiner artificial intelligence products, and paired with Solenis's expertise. Where and what, or not where necessarily, but where in the paper making process are we autonomously controlling, and what are we autonomously controlling?
Sure. We first started out with wet strength specifically. We looked at the
wet strength, the chemical, right?
Yes.
Okay.
We looked at all of the different potential solutions. We see quite a few of them, but it was really the low-hanging fruit, identifying these functional chemistries specifically. So we started with wet strength, but chemistries where you see a very linear move. I make an adjustment, I expect to see this exact same adjustment. There's not, a bunch of different things that are causing this reaction to elicit. So that's why we started with wet strength, and it was very successful. It was a very good, initial start. We're now working to expand that to further things. So, we have a wet strength. We're looking at a sizing. Sizing is another functional chemistry that helps hold water out of the paper. But now, the sky's the limit. We're starting to look at furnish ratios. So what that means is, there's different types of fiber that you can make up your paper with, and some are more expensive than others, and some are stronger than others. And so it's really a balancing act. And it's very challenging for the customer to really understand or have that level of information that they can confidently be making these optimization adjustments. So they'll just run to a recipe. And so this is really where we're starting to see that value and starting to drive it with the customer, is because they didn't have this level of information that the prediction and the autonomous control is providing. We're controlling their fiber source now. So we're using the cheapest possible fiber to get the paper properties that they want. That's the Shangri-La for a lot of these customers. It's big money for them. So, we keep opening up the door for more and more things. We just need to know, what is something that drives value for your or for this customer? What is a KPI that they're looking to control something to? And we're confident that we can build something that's going to drive that value.
That's amazing. So I'm hearing, we're controlling in the pulp and paper industry chemical applications through to fiber ratios and fiber sources, which both are a giant spend on a paper machine. So that is really exciting. What's next? What's next for AI in pulp and paper? Chitta, do you have some insights for us?
So Matt said a nice word, which I want to use. He said, because manufacturers, operators do not know how to make it, they follow a recipe. So if operators are cooks who follow a recipe, AI is a chef, which understands deeper, more.
Ooh. Say that one more time in case anyone in our audience has missed that.
So I don't know if anyone of you know that. So I'm writing a book on deep learning right now, where I draw parallels.
A cookbook.
Cooking, yes. So I'm not writing a cookbook. That's a part, and that's where I said that think of anything like there in the book. I say that think of deep learning as an art of cooking. One way to cook is follow a recipe. But if you know how the food, the spices, and the fire behave, then you can create your own, you can make your own creation. And if only you understand how all of these behave, it transcends whatever you're making, it transcends your creation. And this is where AI excels. Now, humans are limited by how much they can understand the process. And I can explain this also a little bit. Most humans can think in 3 dimensions. Some of us can think in 4 dimensions. Some exceptionally talented people like chess grandmasters can think in 6 dimensions.
And my husband can think in 1.
In 1.
Proud 1D thinker here, so.
Sometimes thinking in 1 dimension works, by the way, in defense of your husband. But yeah, when we come to manufacturing, we have a lot of dimensions. For example, every variable which is affecting your product quality is a dimension, and there are so many of them. There are so many variables out there. Humans cannot think in all those dimensions because we are limited by our capability, but AI is not. If AI cannot do everything humans can do, but AI can do great in one thing that it is trained to do. We train AI to do one thing, which is produce this paper in the right quality specs with lowest possible cost. And AI can do it significantly better than humans can do, just because, as I said, AI is a chef and we can only be a cook when it comes to manufacturing.
Yeah, that's a great point. I mean, that's really where we're trying to move to is, right now we're really controlling one prediction with one lever. And how can we start branching that out to, instead of just one ingredient, like Chitta said, the whole recipe. And understanding, we have now 5 levers and we have 5 responses, and how do we maximize that, so that they're producing it, just like he said, the cheapest possible for, the best quality that they can get. And so we just continue to build those out. We look at more complex chemistries, we look at more complex furnace solutions, and it's very exciting, how bright the future is, because this is huge and everyone's always wanted to do it, but no one's had the level of information to really make these decisions.
Right. Right. So at the end of the day, all of this, and we've thrown out the word cost savings a couple of times here. At the end of the day, our manufacturers in the pulp and paper industry are interested in their bottom line, or increasing their revenue in general somehow. What is autonomous control doing, or how is it showing up as revenue for these manufacturers today?
Sure. So first and foremost, it's chemistry reduction, right? That was the first bucket that we targeted. I think we kind of talked about it a little bit earlier, but of the costs for manufacturing, chemistry, furnish, energy, water, and so we just decided to target one of those buckets. And because Solenis is a specialty chemical provider, it made sense for us to play in that space. So in general, we've been able to reduce chemistry for the wet shrink specifically by 20% for a customer.
Wow.
That's big money for some of these different sites. We're talking, 7 figures potentially if it's a large user. So that's where we started. And now we're working on some of these even bigger ticket items. So furnish is easily a 7-figure solution. If we're able to, optimize their energy usage, that can really lead to increases in production, which is once again a 6-figure, 7-figure solution. So really the sky's the limit here. These are big money-making assets that use a lot of money to make a lot of money. So just a small fraction of an improvement in uptime and raw material optimization, leads to big dollars for the customer.
What are both of your guys's guess? So, to me, it sounds like autonomous control, AI in manufacturing. This is here, it's now, and its future to expand is really bright. How many years in the future until someone who's not adopting this today gets left in the dust? How close are we to that really being a reality?
I'd say very close. We talked about being antiquated, but it's very much light and day. You see some customers that are adopting and moving forward, to data-driven solutions, and they are, leaps and bounds ahead of some of these other guys that are very much stuck in the past. And so it's, especially in this world that, we're seeing paper machines get shut down because, they're trying to optimize their assets as much as possible. It's really a dog-eat-dog world, and I've been a part of plenty of paper machines shutting down, and it's a sad thing to see because it's a lot of jobs going out the door. But if you're not willing to optimize, if you're not willing to be on the cutting edge, it's going to quickly turn into someone else is going to be making that paper instead of you.
Yep, we have an example from things that is happening very recently. If you are not on internet, you are out of business. Specifically, think of restaurants right now. During this COVID time, restaurants could not stay open, but some of them who were online, who had this online system for taking orders online, they stayed afloat. They are still in business. They were taking orders just for takeout and these kind of things. And they were people who were smart enough to invest in this early on, so that if this day comes, I'm sure they would not have foreseen this day, but at least they were smart enough to invest in this technology in time to just live this day. And I think this is what will happen sooner or later. Something like this catastrophic does hit most of the industries, and the one who are early enough to adopt new technologies are usually more prepared to deal with anything like that.
Absolutely.
Great. Well, this has been an awesome conversation, guys. I've learned a lot. I hope our podcast listeners are excited about autonomous control and pulp and paper manufacturing and just the future of AI and manufacturing in general. I'd like to thank both ProcessMiner and Solenis, you guys taking your time to discuss here today this topic on the ProcessMiner University. So thank you.
Thank you. It was a pleasure.
Thanks for having us, Sydney.
Thank you for tuning in to today's ProcessMiner University podcast. Be sure to tune in or subscribe to each podcast and enjoy a new and interesting topic in your quest to become a digital manufacturing expert. Come prepared to learn from highly recognized subject matter experts who will share their knowledge on the latest digital trends transforming our industry. In the meantime, stay safe and innovate boldly.